Hello everyone, my name is Diego, and today I'm gonna be talking about generic collections and data structures. So let's talk about the difference between an array list, and a linked list. So the array is a linear data structure. It serves as a container to hold elements of the same data type. It has a fixed size, meaning that once the array is created, its size cannot be changed. Uh, the array list internally uses a dynamic array to store elements. This means that in contrast to an array, its size can be changed to store data of the same data type. When an instance of an array list is created, it has an initial capacity to store 10 elements. However, once this capacity is reached, the array list needs to resize, which slows down the performance as it involves creating a new array, copying the elements from the old array and transferring them to the new one. The array list has a fast random index access, which means it is faster at retrieving data by index. So the array list is best to use when you plan doing modifications of an array and need quick random access. Alright, now let's talk about the linked list. So the linked list is a linear data structure that uses a doubly linked list to store and retrieve elements. Each element is known as a node, and as the name suggests, it has two pointers, one pointing to the next element and the other pointing to the previous one. In contrast to an array list, the linked list is faster at adding and removing elements since there is no shifting of elements. However, when it comes to accessing data, the linked list provides sequential access, meaning that in order to access a specific element, you need to traverse the list from the beginning until you find the desired node. Depending on the size of the list, this might impact the performance. So linked lists are ideal when adding elements is more frequent than reading them. They also work well in read-heavy scenarios if we mainly access the first or last element, thanks to their efficient operations at both ends. Here is an example of how to create a linked list and an array list, and its basic functions, which would be add for the linked list at first, at last, remove first, and remove last. How to get the value of these elements. And for the array list, as you can see, it's pretty similar. But yeah, we don't have the at first or at last. Talk about the stack and queue. So the stack is a linear data structure that follows the LIFO principle, which stands for last in, first out. This means that it allows insertions from just one side of the list, which is called the top. So think of it as a pile of books where the last book that you added on top is the first one that you're gonna remove to reach whichever that you want. And some of the primary operations related with stack are push, which adds an element to the top of the stack, and pop, which removes and returns the last element of the stack. We can use the stack for backtracking, function call management, and system architecture. Now let's talk about the queue. The queue is a linear data structure that follows the FIFO principle, which stands for first in, first out. This means that the first element added to the list will be the first one to be removed. You can think of it as a line of people waiting for a service. The first person in line will be the first one to be served, and the new people that join the back of the line will be the last. So some of the primary operations related with queue are in queue, which adds an element to the end of the list, and the queue, which removes and returns the first element of the list. So we can use the queue when things don't have to be processed immediately, but have to be processed in first in, first out order. So here's an example of how to create a stack and a queue. For the stack, we're just gonna use the stack class, declare the data type, and assign a name. The basic functions, or the basic function which is push. And then for the queue is a little different. So since the queue is an interface, that means that we cannot really provide the direct implementation of it. in order to use the functionalities of the queue, we are going to need a class that can implement it. That's why we are using the linked list. And here is the one basic function, which is adding elements to the queue. Okay, so now let's talk about the difference between an array and a hash table. Arrays and hash tables are data structures that store collections of values, but these two have different strengths and weaknesses. As we already know, an array is a linear data structure that can store a fixed number of values of the same type in a contiguous block of memory. On the other hand, the hash table is a data structure that stores items in key value pairs, meaning that it uses labels to store elements. It organizes data so you can quickly look up values for a given key, which would be the index. Each of these data structures have properties that differentiate from one from the other, such as size order. The hash table, unlike the array, has a dynamic size, meaning that you can always add or remove items, and it will resize itself automatically. Arrays have a sequential order of insertion, meaning that you can iterate over the elements in the same order as they were added. On the other hand, hash tables do not possess a sequential order of insertion, which means that they could appear in a different order that they were added. Another difference is the duplication of values, which means the storage of multiple elements with the same value, a property that hash tables don't have, unlike arrays. Operations such as access, search, insertion, and deletion are things that arrays and hash tables also differentiate from one another. When it comes to access time, both arrays and hash table have a constant time access. However, hash tables are slightly slower for the collision that may happen when two or more keys may have the same value. And the process to fix this increases the time complexity of the hash table. So, when to use the hash table? Hash tables are useful for tasks such as caching, database, index, storing user information with unique IDs, and managing configurations. You can create a hash table of string keys and integer values. We're gonna initialize it. One, two, three. So here's an example of how we can create a hash table of string keys and integer values. So we're gonna create the hash table, and it is gonna, inside the angle brackets, we're gonna put the data types that it will work with, the name, and then we're gonna create it, right? So then adding elements, we're just gonna use the dot put, and inside the parentheses, with a string, the key that we're gonna use to access the value which we assign next to it.